I found a love for me.
Now that you know how to calculate the empirical formula, let's practice determining the molecular formula. It gives you the molar mass, but first, before I can do anything, I need to determine the empirical formula. So I'm going to take each of these percent compositions, and I'm going to first determine the empirical formula, and then I can determine the molecular formula. So I'm going to take each of these, and you can watch as I go. I am going to convert each of them. I'm going to assume that these are masses, and I'm going to convert them each into moles first. All right, so I'm going to take each of these, figure out how many moles they are. And remember not to over round. I'm going to include more decimals than I normally would. All right, so these are all moles. All right, so I need to divide by my smallest number of moles. And so if you look here, the smallest number of moles is going to be 1.149. So I'm going to divide all of these by 1.149 so I can compare their relative number of moles. And here I get 2.999, which I'm comfortable calling 3. Here I get 6.99, which I'm comfortable calling 7. This here would be 1. And then finally 2.2955. Divide by 1.149. And I get 1.997, which I'm comfortable calling 2. All right, so sorry, this is a little hard to see. This is an 8, that's a 3. But when you write your empirical formula, this is going to be C3, H7, O, and then N2. Now, this is your empirical formula. To determine your molecular formula, you're going to take the molar mass of your molecular formula, which is given to you always, 174.20, or else you would have to do it in the lab. And you're going to divide that by the molar mass of your empirical formula. So I'm going to take 12.01 multiplied by 3 because I've got 3 carbons. I'm going to add to that the molar mass of hydrogen, which is 1.008, multiplied by 7. Add to that the molar mass of oxygen, which is 16. And then add to that 2 times 14.01, which is the molar mass of nitrogen. And I get 87.106. Okay, so when you divide, what you'll get is a whole number. Sometimes it'll be 1, sometimes it won't. If it's 1, what that tells you is that the empirical and molecular formula are the same. Here, it's going to be 2. So to get my molecular formula, I simply need to take my empirical formula and multiply all of the subscripts by 2. So this is going to become C6, H14, O2, and N4. Let's look at one last example. It tells me the amounts, the percents of all of these different elements that I have, but notice it says, and the rest is iodine. So what that means is I have to take all of these percents and I'm going to subtract them from 100% because these all have to add up to 100%. Okay? And when I do that, when I do subtract, what I end up getting is 54.59%. Okay, so 54.59% is iodine. The rest, we have all of our percents. So that was the only kind of tricky thing here. The new added twist was figuring out the percent that is just iodine. So 54.59%. The rest is going to be the exact same as what we did. So I'm going to quickly write out. I'm going to assume I start with a mass of 100 grams. I'm going to write out the masses of each of them and then convert them into moles nice and quickly for you. So to determine the number of moles for each of these, I'm going to take each of their masses and divide by their molar masses. And remember not to over round. So I'm going to include more digits than I normally would. My next step is to divide by my smallest number of moles, which in this case is 0.2148. And I get 9, which is 9.01, which is close enough to 9 for me. And I get, again, very close to 9, 9.006. I'm okay with that. I get 5.00, which is close enough to 5 for me here. This would give me 1. And I get 2.00, which here is close enough to 2 for me. So my empirical formula here is going to be C9, H9, O5, N, I2. Now, in order to determine my molecular formula, I need to take the molar mass of my molecular formula, which is 465, and I'm going to divide it by the total molar mass of my empirical formula here. So 9 times 12.01 plus 9 times 1.008 plus 5 times 16 plus the molar mass of nitrogen, which is 14.01, plus 2 times the molar mass of iodine, which is 126.91, and I get 465.8, which is basically 465 divided by 465 gives me 1. So what that tells me is my empirical and molecular formula are the same. Keep in mind, if you get, once you round by your smallest number of moles, if you get, for example, 1.5, let's say I got 1.5 here instead of a 1, then you're going to have to multiply all of these subscripts by 2 to give you a whole number. But that did not happen in this case.